Welcome once again. This is Amos Mkoje from Top Research Center. Today I want to move on to lecture number 12. In today's lecture, I want to look at two statistical methods which we use to analyze data. And these methods which I'm going to look at are ANOVA and regression. But my main aim is to look at how you perform ANOVA and regression using SPSS Syntax editor. So, as I've already said, the statistical methods which I'm going to look at are ANOVA, analysis of variance, and then linear regression. So today we are using a different data set in this lecture. Let me show you this data set. This is the data set which we are going to use today. We have beginning salary, Saubeck, we have sex, we have time, we have age, salary now, education level, work, job category, race, and job category 2. So I want to perform ANOVA first. In order for me to perform ANOVA, I'm going to use job category as an independent variable, then salary now as a dependent variable, and then I will perform linear regression using salary now as dependent variable and age and beginning salary as independent variables. So initially I'm going to look at ANOVA and then move on to regression or linear regression. So without further ado, let me now open my SPSS Syntax editor. Here I have opened my SPSS Syntax editor. I have already loaded my dataset in my computer memory, and I have divided my syntax editor into two sections. The ANOVA section, so I'm going to perform ANOVA analysis in this section, and I'm going to do my regression in this section. So let us check the variables which I'm going to use in this analysis. Our independent variable which I'm going to use is job cut 2. So let's see the variable frequent job cut 2. I think I made a mistake in typing job freq job cut 2, then dot job cut 2 dot, yeah, this is the variable job cut 2. So you find that we have 4 groups: the security group, the clerical, supervisors, and managerial group. So in one of our lectures, we looked at how we can perform an independent t-test. An independent t-test can only be used when we have only 2 groups. But if we have 2 or more groups, we can now use the ANOVA, because t-test only works with only 2 categories. But in this case, because there are 4 categories, then the ANOVA comes in. So today we want to look at if there is a significant difference in salaries or among these participants or between these groups. if the salary difference is statistically significant between these four groups. So in order to check that, we use ANOVA instead of an independent t-test, because an independent t-test only handles two groups. So the other variable which we are going to use is salary now. Let us check just the descriptives of salary now. Sal now. We just want to inspect these variables before we perform our ANOVA. You find that we have about 474 participants, and we have our minimum salary is 6,300, then the maximum is 54,000, and then the mean we have 13,767.83, then the standard deviation, which is 6830.265. So these are the variables which we are going to use to check if there is a statistical difference in salaries in relation to these four groups: the security group, clerical, supervisor, and managers. If there is a statistically significant difference between these groups in terms of their salary, the present salary they are earning now. So let me go back into our syntax. This is the syntax editor. To get that, we can just type means what is our dependent variable? It's salary now. Means salary now by job category 2, job cat 2, then slash stats. So means salary now, then job cat 2 slash start. Let me run this and see what we get. We have our case summary, we have all the means, and we have our ANOVA table here. From this ANOVA table, you can see that it is statistically significant. The difference in salary, the difference in salary is statistically significant among these participants, or in relation to these four groups. So we can also get this ANOVA table if we enter this command one way, salary sal now by job cat 2. If we run this, you find that we have an ANOVA table again, and this ANOVA table is similar to this ANOVA table. So you can use this syntax or this first syntax, but you get the same. But the good thing about using this approach, you get all these stats. But if you only need the ANOVA table, you can use one-way sol. Now this is the dependent variable by your independent variable, and you get the same result, the same ANOVA table. This ANOVA table and this ANOVA table, these are similar, but I only used different syntax. The other thing which you have to know when you are looking at ANOVA, you need to further inspect to see whether each and every group is statistically significant, or the pairwise comparison of these groups. So in order to do that, you have to perform a post-hoc analysis. You can also do that using SPSS Syntax editor. If I were to come back to this second command, syntax command, and add /posthoc equal to, we have different post-hoc tests like the perforating, the scarf, the techie, but in this case let me just use the techie, then alpha, my alpha in brackets, or we can say parenthesis, 0, 0, 5, then close the brackets and a dot or a full stop. Then if I were to run this, you find that I am now having this extra table which shows the post-hoc analysis. If you go through here, you find that all other subgroups are statistically significant. But if you compare the security officer group and the clerical group, it is not statistically significant. This is the same, clerical and security is not statistically significant, but all other groups are significant. So it is not wise to rely on this. It is important for you to perform a post-hoc analysis to further investigate the groups which you are looking at. So this is how you perform the ANOVA using SPSS Syntax editor. This is how you perform the analysis of variance using SPSS editor, and also how you perform the post-hoc analysis. Before we move on and look at how we can perform regression or linear regression using SPSS Syntax. Now I've gone back into my syntax editor and I want to show you how you can perform regression in SPSS Syntax. As you can see, I've divided it into two. Here again, I have my first model. I'm going to do it here. I have the independent variable as age, which is the predictor, and the dependent variable as the present salary, which is SAL now. But my next model, I'm going to use again salary now, present salary, and my predictors will be age and beginning salary, which is SALBEG, which is saved as SALBEG in our data set. So what I'm going to do is I'm going to show you this first and this second. But I want to remind you that when you are doing regression, there are certain procedures you have to do before running your model. We have to check the linearity of your data using scatter plots. So you have also to check the multicollinearity of your data. So, but in this lecture, I'm not going to go through that. I just want to show you the syntax which we can use to perform regression, linear regression in SPSS using syntax editor. But when you are analyzing data, you have to check the linearity and the multicollinearity of your data before performing any regression analysis. So it is important to check the multicollinearity of your data and also the linearity of your data before performing regression or linear regression using SPSS syntax or performing any regression. But today, as I have said, I'm not going to go through that. So to do that, to do our regression, you have to type, let's rig says regression. You can click here and have a full, but it's okay if you just type reg and then dep for dependent equal to salary now, which sound now, then slash, then you type enter. We now type the independent variable, in this case it's age, and then a dot at the end. This is our syntax, reg slash dep equal to sal now, which is our dependent variable, slash enter, then we enter equal to age, which is our independent variable. Let me run this. This is what we get. This is what we get. You find that we have the variables entered, we have the model summary, and this is our ANOVA table, and we have our model here. So as you can see, it's statistically significant, which means that there is a relationship between age and current salary. So age is the predictor of current salary. And we find that we have the constant, which is now the current salary, which is 16,911, and we have the slope, which is minus 84,550.550, and this can be used to come up with our equation, and the equation will be current salary equal to that constant, and then minus that minus the slope, then times the age. So we can predict the age, the current salary using age of a particular employee using this equation. If we go up there, we can see that the error adjusted is 0.019, and we can multiply this by 100. And if we multiply by 100, it will be 1.9, which means age of an employee could predict 1.9% of the variance in the current salary. So the variability of the current salary can be predicted by using age, and age of an employee could predict about 1.9% of the variance in the current salary. So in general, this is how we can come up with linear or simple regression using SPSS linear regression. Let's say we have reg now, want to add two variables and see what happens. Dep equal to sal now, then slash enter, enter age slash enter. Let's say beginning salary, Saubek, beginning salary, and then dot. Let me run this and see what we get. This is the output. We have our variables, independent variables, age and beginning salary, the ANOVA tables, and if we check our model is statistically significant. As you can see here, it is statistically significant, and we have our coefficients. And if we come now to our adjusted R-squared, you can see that there is big change. In our first model, where we had only age, it was only used to predict, or only 1.9% of the variability in salary. So if we were to use only age, we could only account for 1.9% of the variance in salary. But when we add age now, our model 2, you find that it's about 79.2%. So 79 salary, beginning salary, and age accounts for 79.2% in the variability of current salary. So the age and beginning salary combined, they account for 79.2% of the variability in current salaries of the participants in this dataset. So, which shows that there is a great improvement in our model when we add beginning salary as well. So this is how you perform linear regression and ANOVA using SPSS Syntax editor. But don't forget that when you are looking at regression, you have to check the linearity using either scatter plots, or you can also have to check the multicollinearity of your independent variables. Thank you for watching. I hope this will help some of you in their journey of using SPSS Syntax editor. Thank you for watching. Please comment, subscribe. If you have any question, you can contact me through our Twitter page, our Facebook page, and our contact form on our website, topresearchcenter.com. Thank you for watching.